Okay, good afternoon, pre-AP students. We're going to talk about the atomic structure. It's going to be awesome where you guys will look in your notes. These notes are in Schoology, and you'll see right today's lesson is about atomic theory. So that will cover pages 2 through 6 in your notes. There's a lot of reading to do, but it's all on the test. So I highly recommend you go over it. Now, before we go over it, we'll just show you that on page 2, there's the part about Democritus. We'll get to him in a second. And he was the first person to come up with, he was the first person to name an atom, but he never didn't use any experiments. And so I'll get to him in a second. So then when we start to apply science, we start to come up with laws and reasons for this. So one of them is the law of conservation of mass, which says that matter cannot be created or destroyed in a chemical reaction. You have the amount of matter in the universe is unchanging. You cannot create new matter or destroy matter. Now, the law of definite proportions is really telling us that atoms are going to be the same proportion of mass every time. So for sodium and chlorine in sodium chloride, you'll have the same proportion of sodium as the proportion of chlorine in every atom. That's what that's saying. You'll have the same mass proportion or mass percentage of each atom. No atoms have like different amounts of mass of sodium. Now, the law of multiple proportions is really taking that to the next level when you start looking at them in chemical reactions. So chemical reactions and the compounds can also be quantified as well. Okay, so now let's move on to, you'll have to read that on your own and just glean whatever information you can. So we're going to move on. That's what we just talked about. And really just going to get into our history lesson of atomic theory. So we are going to talk about Democritus. He was that Greek philosopher that was so devoted to his studies that he actually, there's a story that he deliberately blinded himself so he could not be distracted. So maybe not the best person. Now, this is not actually his picture. This is just a picture of someone around that time. It could be his picture, I guess. But yeah, he did not come up with any science. It was all considered philosophy at that point. Him and Aristotle were on two different perspectives. Aristotle believed in four elements, earth, air, wind, and fire. And Democritus said that, well, there was all sorts of elements around. So Democritus ended up being right. Aristotle was just more popular, so they went with him for 2,000 years. And we screwed that up for 2,000 years. So, anyways, so we have talked about these. I just went over them. So go ahead and read them in your notes, and we'll move on to John Dalton, page 3. So John Dalton used to be an English school teacher, and he was actually kind of a weatherman. But yeah, he ended up coming up, and he didn't actually do any experiments, but he kind of furthered Democritus' thinking. He's actually ended up coming up with 5 postulates, okay, or 5 theories. So the first one is that all matter is composed of extremely small particles called atoms, okay? And then atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. Said that atoms cannot be subdivided, created, or destroyed. Okay, it goes along with what we're thinking. He said that atoms of different elements combine in simple whole number ratios to form chemical compounds. And then he said in chemical reactions, atoms are combined, separated, or rearranged. Okay? So he came up with 5 statements that he believed was true. Now, Dalton didn't know anything about protons, neutrons, and electrons at this point. He just thought that matter was just these little billiard balls, and he imagined them as literally billiard balls. That's how he described it. So that's what an atom was. It was just a little chunk of matter. Now, two of these are not correct. They have been disproven. And that is, number 2 is not correct. So there are atoms that have different masses, okay, and those are called isotopes. We'll talk about that later in this unit, okay. And then for number 3, atoms can be divided because we can split the atom now. You know, we can split uranium into 2 different elements. That's called the nuclear explosion, right? We've heard about splitting the atom. So we can do that. We know we can do that. So 2 and 3 are not true, but we still believe in 1, 4, and 5. Those are still good. Now, so an atom is defined now as the smallest particle of an element that retains the chemical properties of that element. Now, here we go. Here is J.J. Thomson. He is the man that really started launching experiments, and this is where we get into real science. Okay, he just studied physics, became a professor. He won the Nobel Prize. Okay, so he comes up with this idea, and he discovers that there is a charge to and the atoms. There's a positive and a negative charge. What he does is he uses a cathode ray tube. So this is filled, this is vacuum filled, and then a gas is filled in this little tube right here. And then it's hooked up by an anode and a cathode. So the electrons flow from the anode to the cathode. So the electron current is flowing this way. Okay. Now what's happening is that as the electrons are flying through, he added a magnet on the top and the bottom, and he was able to deflect that. He was able to deflect the image. I'm sorry, the matter, the gas that was coming out. So how strange! He was able to prove that a magnetic field was able to do that. So if these were electrons right here, these are all negatively charged, which means that they would repel off of the negative charge plate right here, and they would attract to the positively charged plate up here. Because remember, opposites attract. Negative charged electrons will attract to the positive plate. So cool, right? Yeah, that's exactly what I just described to you. With his observations, he was able to observe these cool little things, and then the conclusions say that matter has a negatively charged particles called electrons. So he discovered the electron. Now his is also called the plum pudding model. Now let's see if I can draw a terrible version of this. So if you have a plum pudding, and what he thought is that this whole thing, the whole circle, was a positive charge, and he thought that there was like raisins in here, because that's what, like in like banana nut bread, you know how you have like the little nuts that are in there? These little raisins, right, were the electrons. So, you know, because he's British, that plum pudding was their thing. So, whatever. So that's it. Now, cathode ray tubes were actually still used up until probably the 90s in televisions, because that's how they projected a television. Is they project the image, and they use magnets like inside the box to manipulate that image. But they don't do that anymore because now we all have flat screen TVs, right? So that's essentially how that goes. Electrons would go through here, through an electron gun, and then you have the magnet plates. Okay? So now we have discovered the electron. Now we need to discover the charge. That would be Robert Millikan. That is his ideas. He discovered the charge of an electron. He also won the Nobel Prize and was an awesome tennis player, apparently. So he was actually American, which is awesome. Because America, right? So what he was able to do is he did the oil drop experiment. Now, bear with me here. So he still has these charged plates, right? So this one's a positive charge. This one's a negative charge. So now he's looking at electrons, correct? So he actually has these atoms, right? I think he just has oil, right? And it's almost like a perfume sprayer right here within an atomizer. So he sprays those and they become little bitty droplets. So he knows the masses of these droplets because he's been able to measure them. And these droplets fall through the plate, and then some of them fall through a very tiny hole in this plate. Okay? So some of them fall through in a very steady stream. And then when they get to a point, they will repel off of the negative charge, right? So he's able to tell when they start to float in between off of the negative charge and the positive charge. And he's able to look through it through here, which is really cool, really clever. So he knows the charge of the current, so therefore that must be the charge of the electrons. Okay? So he's able to figure out the charge of an electron, which is really awesome. Now, Ernest Rutherford comes along, and Rutherford was actually Thomson's student, which is also cool. He won the Nobel Prize. Rutherford was able to discover. This is what we knew. We thought we knew. He went out to prove the plum pudding model. All right. So he did a gold foil experiment to try to prove it. Well, what he actually figured out was that. Hold on a second. Well, sorry. Yeah, I got my slides all weird. So he did what he figured out is he did this experiment where he had a radioactive source which emitted alpha particles. Now remember, alpha particles are positively charged, so positive charges are coming out of here. Think about a plus sign shooting out of here. Now they go through a very tiny slit, right, tiny hole, and then they hit this very thin sheet of gold foil. Okay, so what he finds is that most of them go straight through. Okay, because strange. He finds that the electrons or the positive charges are going straight through. So they're not hitting anything. Okay? Empty space. They're not hitting anything. Now he finds that some of them are going to the atom, and then because they're positively charged, they're hitting the nucleus in the middle and they're bouncing backwards. Okay? So that's why you get these deflections right here. They hit the nucleus. So very infrequently he's able to figure out that, like, kind of how big the nucleus is. So he's the first person to discover that a nucleus exists, or that the positive charge exists in the nucleus. Now, just to give you an idea of how much like empty space there is in an atom, just imagine that you're at downtown Bryan and you're holding a basketball, okay, and if this basketball was the size of a nucleus in downtown Bryan, the electron would be out to OSR, okay? So that's how far away the electron is. That's how much empty space is in an atom. Like, the nucleus is very, very tiny. So, now, Chadwick is also Rutherford's student. So, and he invents the neutron. It is so crazy that student after student after student invented all three subatomic particles. So he discovered the neutron. He figured this out, and he was actually a prisoner of war in World War I. Okay, so he wins the Nobel Prize in physics, and yeah. So now, let's move on. We have Niels Bohr. Niels Bohr is the person, we'll talk more about him later, about his planetary model, but he comes up with this idea. He knows the nucleus exists with protons and neutrons. He knows the electrons are around. So now he's really focusing on the electrons and what is going on. So he knows the electrons aren't just staying in place. He figures out that the electrons are moving. They're somewhat in motion. So he comes up with this model that looks like this. Most people think of the atom as looking like this, even though that's actually still out of date. So the atom is moving around in a planetary model. Now the problem with this is that this is negatively charged, this is positively charged. They should attract. So why doesn't this electron just collapse into the nucleus? Good question. All right. So that's why we have this guy, which is Erwin Schrödinger. He comes up with a quantum mechanical model. Now, the math in here is way, way beyond your level to understand, but he figures out that the electrons are not orbiting the nucleus, they're just existing in some kind of probability here. So this is what we call the electron cloud model. All right, it comes up with some probability that the electron exists in some area. Now, yeah, it's a probability thing. So, summarizing that whole thing. Whew, wow, that was a lot. We walked through all the important people. Yes. So the atom is the smallest particle of an element that retains the chemical properties of that element. The nucleus is composed of protons and neutrons, and it's a positively charged center. Since the neutron has no charge, the nucleus must be positively charged. The nucleus is also extremely dense, and it takes up an insignificant fraction of the atom's volume. Right? There's a lot of empty space in an atom. So it's, the volume of the atom is almost negligible. That's why it's so dense. Now, the proton is positively charged because it has a +1 charge. Found in the nucleus, it is 183 times more massive than an electron. Its mass is 1 AMU. We'll get to that. Now, a neutron has a 0 relative charge. It has the same mass as a proton, and it's also found in the nucleus. Now, electron has a -1 relative charge, and then it's found outside the nucleus. That's really all you need to know. Okay? So, you should go back through this video and try to find a picture of this atom and then the name of the models. Hopefully you were doing that before. If not, just scroll back and rewind. Now, what you need to know off of this, you need to know that an electron has the E- symbol. So if you see me write that, that's what that means. It has a charge of -1 and a mass number of 0. Okay, we'll just call it, it has no mass, it's negligible. It's so small. Now, the proton is P positive. It has a charge of +1, and its mass number is 1 AMU. Okay? And then the neutron is N0, no charge, and its mass number is also 1 AMU. That's what there'll be more about this a little bit later. So that's essentially it, guys. Thanks for sticking with me in this boring history lesson. But we won't have to do a history lesson again. So, congratulations. Have a great day.